Hello everyone. Let's solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start with the question number 1. Okay. Question 1 says the condition for which the eigenvalues of the matrix A are positive. Okay. So we have to find the condition of for K such that the eigenvalues of this matrix A are positive. So we have to find the condition that the eigenvalues of this matrix will be positive. So let's assume lambda 1 and lambda 2 will be the eigenvalue of this 2 cross 2 matrix A. So let's lambda 1 and lambda 2 are are positive. Okay. So now we simply just use the property of this eigenvalue, uh, which are the sum of these two will be the trace of this matrix, and the multiplication of these two will be the determinant of this matrix. So lambda 1 plus lambda 2 equal to the trace of this matrix, which is just summation of these 2 and k. So 2 plus k. Now lambda 1 is also positive and lambda 2 is also positive. So this 2 plus k must be a positive number. So we can write 2 plus k will be greater than 0. Now from here we can say k will be greater than minus 2. Okay. Now we also need to use the second property, which is the multiplication of this two eigenvalue is just simply the determinant of this matrix. So again lambda 1 multiplied with lambda 2 equal to the determinant of this matrix, which is 2k minus 1. So again lambda 1 and lambda 2 are positive, so multiplication of these two positive again give the positive number. So we can say 2 minus 2k minus 1 will be greater than 0. So here we can say 2k is must be greater than 1 and k must be greater than 1 half. So here we got the condition. First condition says let draw this condition on this axis. Let's suppose this is the represent the value of k. Now the first condition is says here minus 1, here minus 2, 1 into this first condition says the value of k must be greater than. So we have select the value of k from this range. We cannot select k from this range. And the second condition is says that k must be greater than 1 half. So 1 half is somewhere here. So second condition is says the value must be greater than 1 and a half. So this is the only region, this one, this is the only region this satisfy this both condition, this first condition and second condition. So we can say the k must be greater than 1 and a half. So we can uh, say that the option C is the correct condition for the k. Okay, let's move on the question number 2. Question 2 says the number of linearly independent eigenvectors of a matrix A. Okay, we have given matrix A which is 3 cross 3, and if you look this matrix A, then you observe it is nothing but just upper triangular matrix, because the all the entries below the diagonal are 0, and either the matrix is upper triangle or lower triangle, uh, its diagonal entries are itself as an eigenvalues. So we can write the eigenvalues of this matrix A will be just simply this diagonal element, which are let call lambda 1 equal to 2, lambda 2 equal to 2, and lambda 3 will be minus 3. Now we know that if we get the linearly independent eigenvector if and only if the eigenvalue corresponding this eigenvector are distinct. So here we can say these two values are same. So we are not getting here uh, two linearly independent eigenvector for this lambda 1 and lambda 2. We just getting simply one eigenvector which, and if we try to find the other which is linearly dependent. So we cannot find linearly independent two vector for this lambda 1 and lambda 2, but we can find for lambda 3. So after all we get just simply two eigenvector which are linearly independent. Okay, because here the eigenvalues are repetitive. If all three eigenvalues are distinct, then we find three eigenvector and which are linearly independent. But here the this lambda sorry this eigenvalue 2 has a multiplicity of 2 because it is repeat twice. So we are simply just getting two linearly independent eigenvector. So here we are getting, so they are asking about the number of linearly independent eigenvector, so which equal to 2. Okay, let's solve question 4. Question 4 says the a real square matrix is called q symmetric. Okay, recall what is the skew symmetric matrix. If any matrix and we are taking the transpose of this matrix and we are getting just simply the transpose of this matrix is same matrix but multiplied with minus sign. So it is the condition for the skew symmetric matrix, or you can call it a definition of skew symmetric. If any matrix is the same as its negative of transpose, then we call it q symmetrics. Or you can write in the other way like A transpose equal to minus A. So we can say that the condition B is the correct one that describe the skew symmetric matrix. Okay, let's solve question 4. Question 4 says consider the linear system. Okay, we have three equations in terms of x, y, and z, and right hand side are unknown, which are in terms of ABC. The system is consistent if A, B, and C satisfy the equation. Okay, uh, we have to find the equation in terms of ABC. If this equation will be satisfied, then and then this system will have solution. So first of all, let's find the augmented matrix from these three equation. So we just simply let's write here 1, 2, minus 3. On the right hand side of the first equation we have A. From the second equation we get 2, 3, 3, and B. From the third equation we get 5, 9, minus 6, and C. Okay, now let's perform some row operation to uh, reduce this matrix. Okay, so first of all let's subtract 2 times R1 from R2, 2 times R1, and let's subtract 5 times R1 from R3. So after that what we are getting, the first row is remain as it is. Here we have A. The second, in the second row we have 2 and we are getting minus 2 from this element, so we are getting simply 0. Here 3 and we are getting minus 4, so minus 1. Here 3 and we are getting plus 6 from here, so plus 6 plus 3 we are getting 9, and here we are getting B minus 2A. Okay, now in the third row we are getting minus 5 from this first row and we have plus 5, so we are getting 0. And here 9 and we are getting minus 10 from this first row and we have plus 9, so we are getting minus 1. again we are getting plus 15, we have minus 6 there, so we are getting 9. Let's check, uh, plus 15 minus 6, okay, plus 9, and here we are getting c minus 5a. Now you can see, if we subtract this second row from this third row, then this both entry will cancel out. So let's do it. Okay, let's r3 plus, sorry, not plus, we have to subtract r3 minus r2 will gives new r3. So let's write again this a. Okay, we have plus 1 from this second row, we already have minus 1, so we just getting 0. Again we are getting minus 9 from this second row, we have plus 9, so we get 0. Now here c minus 5a remain as it is, minus we are getting from this second row is minus b plus 2a. Now let's simplify this uh, last entry. So 1 2 minus 3, here a remain as it is, 0 minus 1 9, b minus 2a, and here all entries are 0 except this last one. So here we just simply getting 2a minus 6b minus c. Now they are asking about uh, the condition of this a, b, and c that must be satisfied such that this system is consistent. So okay, I did a mistake here. So let's erase here. Uh, what we are getting is just simply minus 3a, because we have minus 5a and plus 2a minus b plus c. Okay, that is we are getting. So now if this system is consistent, then we can say that the rank of this matrix a, rank of this a will be exactly same as this rank of augmented matrix as a whole. So if this third, this last entry will be 0, then and then this condition will be satisfied. So we can equate this equation minus 3a minus b plus c equal to 0. Now if this a, b, and c will satisfy this condition, then and then we get the rank of a is the same as this rank of this augmented matrix. So we can say the system is consistent if and only if this ABC will satisfy this condition. So now look at the option. Okay, let's multiply this equation with minus sign. So we getting 3a plus b minus c equal to 0. So now this is the condition that these three variable a, b, and c must satisfy. So we can say option A is the correct condition. 3a plus b minus c equal to 0. So option A is the correct option. Okay, let's move on the question number 5. Question 5 says a set of simultaneous linear algebra equation is represented in the matrix form as shown. Okay, we have 5 equation in terms of x1, x2, x3, and x4 and x5, and they are described in the matrix form, and they are asking about the value of this x3, this variable. So now we first of all let's form the augmented matrix. So here 0 0 0 4 13 2 5 5 2 10. Okay, now we have to find the value of x3. So just reduce this matrix little bit, so we can find the value of x3 easily. So let's do some row operation. If we look carefully, then we can see this first row and this fourth row look like very similar. So what we are simply just let just subtract this first row from this fourth row. So r4 minus r1 gives new r4. So let's write what we are getting after that. 0. Now here 4, and we get minus from this first row. So we are getting here 0. Here 5, and we are getting minus 13. So we are getting minus 8. And on the here we have minus 46. We have plus 30. So we are getting minus 16. Now the last row will remain as it is, 2, 3, 2, 1, 5, and 81. Now let's just find the value of variable what we are getting from this matrix. We don't need to further reduce this matrix because we can find the easily value of this x3 from this matrix. So first of all, let's compare this. So we are getting minus 8 x5 equal to minus 60 from this row. From this row, fourth row, we are getting the value of x5. So what we are getting, x5 is an x5 is an 2. So we got the value of x5. Now from this first row we can get x4 because we already know the value of x5. So let's put 4x4 plus 13x5 equal to 46. So x5 is 2, so we get 26. We have to subtract 26 from this 14, 46. So we are getting x4. Okay, 26. So we are getting simply 20. So we get x4 is an 5. Okay, now from this third row we get the value of x3 because we know the value of x4 and x5. So 2x3 plus 5x4 plus 3x5 equal to 61. So let's simply put the value of x2 and x5 and x4. So 2x3, here x4 is 5. So 5 multiply with 5, 25. Here x5 is 2, so we get 6 equal to we have 61. So 2x3, here we are getting 31, and we here we have 61, so we getting simply 30. So we get x3 equal to nothing just simply 15. So that's it. They're asking about the value of x3, and we are getting 15, the value of x3. Okay, let's solve question 6. Question 6 asking the rank of this matrix. So simply we have to reduce this matrix. Let's simply write here. So now let's r3 minus 3 times r2 gives new r3, and r1 minus 5 times r2 gives new r1. Let's write what we are getting after this. Now in the first row we are getting 0 as a first element because we have plus 5. We are getting minus 5 from this second row. Here 10 as it is. Here we are getting again 0. Okay, the second row remain as it is. Now in the third row we are getting again 0 here. Here again we getting 6 remain as it is. Now here again we are getting 0 because we have multiplied this second row with minus 3 and adding in this third row. So we are getting minus 6 from here, and we already have plus 6. So we simply get again 0. Now you can see this row 1 and row 3 are linearly dependent. So we can again reduce it, but we simply find the rank from here. It is just simply 2 because these two rows are linearly dependent. So the rank of this matrix, let's say, is M, will be 2. So correct option is the B. The rank of this matrix will be 2. Okay, let's solve question 7. Question 7 says consider the following statement about the linear dependence of a real value function. Okay, we have given three functions, y1 as in 1, y2 as in sorry, here not x1, simply x, and uh, y3 as an x square. Here simply just we have x. Okay, and over the field of real function. Okay, so we have a first statement about the linear dependencies of these three function. So what we are going to do to check whether these function are linearly dependent or independent, we just simply form the Wronskian of these three function. We are we are making the Wronskian of these three function and find the determinant of this Wronskian. And if we find the determinant of the Wronskian equal to 0, then the functions are linearly dependent. And if the Wronskian of these three function will not equal to 0, then the functions are linearly independent. So how to form the Wronskian of these three function? So first of all, let write three function in the first row. Here it is x square. Now what we have to do is just differentiate this function here, and write after what we are getting after differentiation at here. So we are getting 0, here we are getting 1, here we are getting 2x. Now in the third row we have to again differentiate this function. So simply differentiation of 0 is 0, differentiation of 1 again 0, and here differentiation of 2x simply 2, and we have to find the determinant of this Wronskian. Now remember that we are getting three function, so we have to differentiate up to second order. So here the simply just three function, so we have to differentiate up to second order. Let's write in the general form. Let's suppose we have to find the Wronskian of any function, sorry, any uh, combination of function. So just simply let's call it f1, g of x, and s of x. So here we have to differentiate first function, and write the differentiation of this function here. We have to write the differentiation of second function and the third function. Now similarly we have to do the second differentiation and write in the similar, sorry, here it is z and here s, and that's it. We have formed the Wronskian of this three function, f of x, g of x, and h of x. Now here we have to find the determinant of this matrix. So let's find the determinant. Now you can see it is an upper triangular matrix. So just determinant is the multiplication of this diagonal element, which are 1 1 and 2. So the determinant of this matrix will be 2. So we are getting determinant as a non-zero. So it means these three functions are 1, x, and x square are always linearly independent. Okay. So let check one by one all all statement. Statement 1 says y1, y2, y3 are linearly independent on. Okay, they are saying they are linearly independent, but here the condition is given in terms of interval, because here the determinant is independent of x, it is not dependent on x. we are getting the constant term. So of whole real value we are getting whatever value may be x take, we are just getting the determinant as 2. So these three functions are independent of each other in the whole this real scale. So this option 1 is true because they are, because here it is given the interval, but if the interval is not given and simply just given on the whole real line, then we can say still the statement is true. So statement 1 is true. Now let's move on the statements 2. Statements 2 says y1, y2 and y3 are linearly dependent. No, because they are independent. We can say from this Wronskian. So option, sorry, statement 2 is wrong. Now option statement 3. Statement 3 says y1, y2, y3 are linearly independent on 0 to 1 interval. Okay, in this interval again, this is the true statement. Now statement 4 says y1, y2, y3 are linearly dependent. Again, they are not dependent. They are linearly independent. So statement 4 again false. So we can say the true statement are only 1 and 3. So option B is the correct combination of this two statement. Both 1 and 3 will be true. Okay, let's solve question number 8. Okay, question 8 says a sequence uh, x of n is specified as, okay, we have given the sequence in terms of some matrix and we have condition for n is greater than or equal to 2. The initial condition we have given x of 0 equal to 1 and x of 1 equal to 1 and x of any number n which is less than 0, we are getting the output as 0. Okay, they are asking the value of x of 12. Okay, so let's write here 12 in the place of n in the above matrix equation. So what we are getting, let's write here simply x of 12. Now here we are getting x of 11 because we have to subtract 1 from this n. Now on the right hand side, what we are getting, 1 1 1 0 raised to 12 and here 1 0. Now we have to just simply find this 12 power of this matrix and we have to compare this element x of 12 on the left hand side and with this the right hand side, then we end up with the value of x of 12. Now to find the value of this matrix uh, power 12, we use the Cayley-Hamilton theorem, which is says that uh, any matrix satisfy its own characteristics equation. So let's form first of all characteristic equation of this matrix. So let's form here 1 minus lambda 1 1 here minus lambda, find the determinant and equate is equal to 0. So we are getting simply just minus lambda into 1 minus lambda minus 1 equal to 0. Let's multiply this minus lambda plus lambda square minus 1 equal to 0. So we can say lambda square equal to 1 plus lambda. So now from the Cayley-Hamilton theorem, we can say that this matrix, let's call it A, this matrix A will satisfy this equation. So let put A at the place of lambda in this equation. So what we are getting, just simply A square equal to A plus 1. Okay, now we have to find the power of this matrix agent 12. So we have to find the A raised to 12. Here we call this matrix agent A. So here we can write this A to the 12 is just simply A to the 6 multiplied with A to the 6. Now we have find out this A square in terms of A. So if we cube this equation, so we are getting a to the 6. So let's cube this equation 1. So what we are getting here, 8 square to the cube. So here just simply we have cube, we have to cube this right hand side also. Now expand this, so we are getting a cube here, now plus 1 plus 3a plus 3a square. Now let simplify this further. So now we can write a cube as in a multiplied with a square, a multiplied with a square. Now this one remain as it is, because we here, sorry, we have to write the identity matrix because this is an a matrix equation, so we cannot write one, we have to write the identity matrix. So we have to write here also the identity matrix. This identity matrix remain as it is, plus 3a. Now these three, now replace this a square with this a plus I, simply a plus I. Now here again, now again replace this a square with this a plus I. So let's do the some simplification. So we're getting simply 6a, 3a here, 3a, and we are getting 4a. Now if we multiply this a with this bracket, we are getting a square, plus again we are getting a, we already have 6a, so we are getting 7a plus 4i. Now again replace this a square with this a plus I term. So we are out, we are getting, we have to add this uh, further 1a in this 7a, because we are replacing this with this value. So we are getting 8a plus, we have to add also 1 in this equation, so 8i. Oh, sorry, I did a mistake here, here not 8 but 4i, and plus 1i from here a square, so we are getting simply just 5i. So here we are getting 5. Let's write here 8a plus 5i. Okay, so we get uh, a to the 6th power. So let's again square this a to the 6, so we get a to the 12. So here let's square this a to the 6, which is nothing but simply just a to the 12. So let's square this equation, which is 8a plus 5i to the square. Let's expand this square, so 64 a square plus here 8 multiplied with 5 multiplied by 2, so we are getting 80a plus 25 I square, which is again the I. Okay, now again replace this a square with this equation, so we are getting simply 64a plus I plus 80a plus 25i. Let's simplify, uh, let's add this 64 with this 80, so we are getting 100 144a plus, now let's add this identity 64 plus 25, which is 89, so we are getting 89i. Okay, so let's form this, we are getting a to the 12. So now let's put value of a here and the identity. So what you are getting 144. Now we have to put the value of a in terms of matrix. Now plus 89 in the 2 cross 2 identity matrix. Now let's find out the resultant matrix. So here 144 plus 89. So we are getting first element as 233. Now here at the in the second element we are simply just we have to multiply this row with this column. So let's do it. Sorry, we have to just simply the add. Here we are getting 144 plus 0, so simply 144. Now in the third element we again get 144. Now the last element we are getting simply 89. Okay, so we have find out this a to the 12 power. Now we have to do the multiplication with this vector 1 0. So let's write this a to the 6 matrix, sorry, a to the 12 matrix here, which is 2 3 3 1 4 4 1 4 4 89. And let's do the multiplication with this vector. Now what we are getting, just simply here we have to multiply this first row with this. So here simply 233 and here 144. Now we have to compare just simply this x of 12 with this 2. Let's write further. We can say x of 12 and x of 11 equal to 233 and 144. So we can compare and we can say that the value of x of 12, it is nothing but simply 233. So that's it, we have done. We have find out the value of x of 12, which is 233. So it's our answer. And thanks for watching this video.